Hello, this is Susan Poss again. I'm working in Chapter 5, Section 1, and we are adding up many exponent rules here. We've done the multiplying like bases rule. We've done the what happens when you have a base raised to the power 0, and now we're going to be looking at the quotient rule. All right, so this time, of course, quotient means divide, and you can see the example here is a quotient. It's an x to the 5th divided by an x to the 3rd, so that makes it a quotient. And what I've done here is I've gone ahead and expanded this out for you so that you can see 5 factors of x up in the numerator and 3 factors of x down in the denominator, and all the matching common factors I've canceled out. So what remains is x to the 2nd, and notice that it's in the numerator, so I can just write it x to the 2nd. So I hope you're already noticing that what happened there, since the bases were alike, is that if we start with the exponent in the numerator and subtract the exponent in the denominator, we would arrive at the answer that we got by doing all that expansion. So that's a quicker, faster way to get to the result. So on the next one, we have a numeric base, 5 raised to the power 4, divided by, there's our quotient, 5 raised to the 2nd power, and again you can see I've expanded it and done some canceling here, and I hope you see that I have 5 to the 2nd sitting over 5 to the 1st, which is, of course, 5 to the 2nd. So the shortcut for 5 to the 4th, or the derivation of the rule is really what this is keep the common base, and start with the exponent in the numerator, subtract away the exponent in the denominator, and that order is very important. You always start with the one in the numerator, subtract away the one in the denominator. Don't forget that. Start with the one in the numerator, subtract away the one in the denominator. All right, so there's our quotient rule. It says if you have a base a raised to the power m divided by a like base a raised to the power n, that you can write down that base one time and then subtract, starting with the exponent in the numerator, subtract away the exponent in the denominator. So I'm going to work a couple of examples here for you. All right, so on the first one, I see I'm going to separate out the letters, the like bases, into 2 distinct quotients. So I'll be sure to keep the like bases together. All right, so as I do that, this becomes a to the 4. Remember there's a 1 here. 4 minus 1 times b, write the base down once, start with the exponent in the numerator, subtract the 1 in the denominator, and it looks like we end up with a to the 3rd, b to the 6th. All right, same thing here. I like to pull apart the matching bases. So this becomes, write down the base, subtract exponents, are always beginning with the 1 in the numerator and subtracting away the 1 in the denominator. So this looks like this is going to be, what is that, x to the 9th times y to the 4th is your result. All right, so those first two had 1s out in front as the numerical coefficient. Now we're looking at some that have numbers other than 1s out in front as the numerical coefficient. So you want to, again, separate it out, but I like to do one ratio or one fraction or one quotient with the numeric part and additional quotients with the variable parts, making sure that you keep the like bases together. So this first part is just division of numbers. So you're going to take 15, divide it by 3, and you're going to get 5. With the base, you write the base down once, and you subtract the exponents So it looks like here we're going to end up with 5x to the 12th. All right, so same thing here. Create a fraction that involves the numeric coefficients. Create another fraction that involves the base a, and I'm going to create a third fraction that involves the base b. All right, so numeric part, 24 divided by -2 is -12. Write down the base a and subtract exponents. Write down the base b and subtract exponents, and then sort of finish it all up. Notice there is a 1 there, and I'm not going to write down that 1. All right, last example. 18 divided by -6 times x to the second divided by x to the second times y to the 7th divided by y to the 3rd times z to the 3rd divided by z to the 1st. All right, so numeric part, 18 divided by -6 is -3. This becomes x to the 2 minus 2. This becomes y to the 7 minus 3. And this becomes z to the 3 minus 1. And on this one, you have to go one step further. Because remember, we just did our rule in an earlier video, any base other than 0 raised to the 0 power is equal to 1. So what I really have here, sitting in that spot, let me put it in red for you, is a 1. So you might want to just think of, here we go multiplying by that multiplicative identity 1, so we just get -3 here, and then we write down the y to the 4th, z to the 2nd, because the x variable became equal to the value 1. All right, so here's some. I've already got them worked out. Again, I thought I would just scroll and put those on the screen for you. And maybe you could practice those on your own and check to make sure that you're getting the same results that I've got. Okay, so that's our quotient rule. So now we have a product rule, a zero exponent rule, and a quotient rule.